All right, so final video of week 5, final video on our 3-part severe thunderstorm series of lecture videos focusing on hazards and safety and impacts of severe thunderstorms. Again, deferring some things till next week, but this is our main focus on severe thunderstorms. So to start off, the hazard we'll talk about first is hail. So hail forms when you have a strong updraft that's going to carry water droplets above the freezing level, and they thus become supercooled. They don't necessarily freeze as soon as you drop below 32 degrees, but what they do become is supercooled, so that as soon as they impact something that is already ice, or something that is enough ice-like in geometric structure, it'll then solidify and freeze. So that tends to happen with small ice crystals that have already formed near the cloud top, and those eventually, through processes of deposition, so vapor coming onto it, and supercooled droplets that are small enough that reach up there, those tend to start to fall. So small ice crystals end up falling, collecting supercooled droplets, and they start aggregating together, and that is what we call graupel, when you have frozen precipitation that's formed from supercooled droplets aggregating onto it. And some of this graupel will end up falling into or near the updraft region. And what that allows the graupel to do is start getting more and more of this updraft carried supercooled water droplets, so that you just keep on getting more and more liquid precipitation coming onto this frozen precipitation core, and it keeps growing and growing and growing. And there are sort of two hypotheses, and based on what I've seen of the research, both of these end up happening, where you get these graupel nuclei, or what ends up becoming hail, slowly falling through the updraft, and just more, and as it spins and rotates, it gets more and more covered in supercooled droplets and grows until it's eventually so heavy that it can't be held up by the updraft anymore, and it falls out as hail. Or sometimes you also get strong enough updrafts where these proto hail cores, these collections of graupel, or start getting hail itself, starts actually going up and down and circulating in convection currents, essentially, within the updraft. And this recirculation and growth process is really driven by updraft strength. So the stronger your updraft is, the more likely you're going to get hail formation, the larger hail formation you really can get. And again, it's through that circulation of these smaller bits of frozen precip growing through more and more supercooled droplets. And sometimes these will sink below the freezing level, ends up melting their outer surfaces. The inner part remains frozen, which allows them to sort of smooth out and get a little more glossy appearance, which you oftentimes see once hail falls to the ground. And so, talk about sizes of hail. Again, it's best if you just want exact size, just straight up measure it, but you'll hear a lot of different names as sort of shortcuts or shorthand references for the size of hail. And again, if you're a nerd like me, you might have something actually like this as a hail ruler to measure things like that. But if you don't, there's useful things that you can do to estimate it. So pea size is typically your smallest named size of hail. Then we go up to dime size, nickel, quarter, half dollar, your US currencies. Quarter size is an important dividing point, because that's about where our 1-inch line is, which is what makes hail from being considered non-severe level to being severe thunderstorm level hail, is quarter size. But above that, we have half dollar, golf ball, tennis ball, baseball, softball, grapefruit. You get a lot larger sizes, but those are much more rare. The one thing you may hear used, which is a bad thing, I try to discourage, and a lot of meteorologists tend to discourage this, is marble sized. It's a bad sizing to use, and if you're reporting to the National Weather Service, do not use marble size because it's kind of a useless measurement because there's no standard size of marble, so it's not a meaningful reference point. All these other ones, pea, dime, nickel quarter, $50 golf ball, tennis ball, all of those have standard sizes, so they're good reference points as a shorthand for hail size. Don't use marble sized, please. If we talk about hail impacts and damages, these tend to go up with the size of the hail. So you tend to get worse damage and worse impacts when your hail is larger size, or there's just more of it, or it lasts longer. Vehicles, these are very typical things. Probably if you're from around the central US, you know very well what hail damaged vehicles can look like. You get dents on the hoods and on the roof. If it's particularly bad enough, you can get broken windshields. Some people like this because you can get used car sales after significant hail events, but it still results in damages and economic loss. Buildings tend to see for just standard hailstorms because it's on the impacted surface, shingles, roofs get damaged from this. But if you have wind-driven hail where you have enough wind speed combined with the hail that instead of falling straight down, you're actually getting sideways falling hail, you can also get siding and window damage on buildings from wind-driven hail. And finally, crop damage is definitely a significant source of impact from hail. So safety tips in general from hail, really you just have to avoid it. So stay inside, stay away from windows. If there's time allowed to protect your personal property, like your vehicle, move those under cover or inside a garage if you have time to safely do so. Of course, your life is more valuable than any property, so protect yourself and stay inside. If you don't have enough time to take care of your property, those can always things be replaced or insured. Hopefully, if you're living in a part of the country or part of the world that sees hail damage, hopefully you have good insurance that covers these kinds of things. And if you're driving and you don't have the chance to get inside yourself, really the best thing for hail storms is you just kind of have to avoid the affected area, or you hope that it's not as bad, because the only place that's a source of cover from hail are really overpasses on highways, and those are very, very dangerous places to be in thunderstorms. Does protect you from the hail, it gets you out of the rain, but it puts you at a really, really bad risk for wind and tornadoes because they can act as wind tunnels essentially and accelerate the wind, accelerate debris that's being picked up. So don't hide under overpasses. So if you're driving and you're running towards a hailstorm, turn around, drive perpendicular to it, get out of its way. And if possible, find a garage or somewhere that's actual more sturdy structure that won't cause wind tunnel-like acceleration like an overpass does. So, talking about wind, our next hazard. This is associated with the outflow of a thunderstorm. Going back to, we talked about bow echoes and derechos, sometimes that outflow of just the main primary outflow of the thunderstorm itself is strong enough and intense enough to be considered severe straight line winds. If you're around Iowa for the big derecho right before classes started, that was one of those cases where just the strength of the system itself with how fast it was moving forward and the wind that was coming out from the outflow added to that was strong enough to be severe on its own and be fairly substantially severe. But sometimes not just the general outflow or the general downdraft from the storm, we can also get localized increases in localized particular columns of sinking air beyond just what the general outflow is. And these are called microbursts. These are intense localized columns of sinking air. They can be wet microbursts where there's precipitation inside these, or dry. Either can happen depending on the dynamics and thermodynamics of the system. But in either case, really they form because you have dry air and strong winds in mid-levels that picks up moisture as it goes through the storm. It cools because that liquid and ice wants to evaporate or sublimate, go into vapor phase in order to try balancing out the dryness of the air, but that causes it to be cool and become more dense. So if you have enough of that happening, i.e. dry enough air, and you have enough strong winds to add and give it an initial kickstart, that combined with low level moisture so it doesn't entrain all the extra air once it goes down, can end up creating really strongly sinking air, which forms these intense localized columns, which are microbursts. And once they impact the ground, that's where they actually really do their damage, because you have air strongly sinking down, and even if it doesn't have as much velocity starting out on its own, once it hits the ground, it's forced to diverge. It can't go anywhere else, but there's a lot of this dense air, and it accelerates outward rapidly once it makes contact or near contact with the ground surfaces. And so this is where you get really bad straight line wind damages from these microbursts. The other thing is, because you can sort of see this downdraft of air here, you get these updraft and these currents going around. These are really bad for aircraft because you can go in order to, they experience one type of pattern, they have to adjust their flight pattern one way, but as soon as they shift from this sort of turbulent regime over to the downdraft, you lose angle attack, and this has tragically resulted in a lot of aviation accidents where these have been poorly forecasted or poorly detected. And in a broad sense, if you don't have really nearby radar coverage, these are really difficult to detect, because if you're far away where you aren't picking up on these direct signatures near the ground, your best bet is actually just looking at mid-level convergence signatures. And those don't necessarily always lead to these microbursts. So it's a hard problem to try detecting these on radar for warning purposes, unless you're basically right on top of where it would occur and really close by. And so severe wind impacts and damages can really damage anything that's exposed to the wind, buildings, crops, trees particularly. And these are all pictures from that August Iowa derecho that I referred to earlier. Safety tips for this. This is kind of a recurring pattern when it comes to severe thunderstorm hazards. Stay inside an interior room, and particularly for severe wind, you want to be away from windows that could be damaged by debris that comes through and breaks the windows and could fly into the interior or the building that you're inside, or by walls that could be damaged by falling trees. Again, tree damage can be particularly bad with severe wind because of foliage picking up and having a lot more surface area to be forced down by severe wind. Another thing to keep in mind is if you're in a manufactured home, those just don't have the structural integrity for the worst of to hold up to the worst of severe wind. So you don't want to be inside one of those if there's enough severe wind to collapse the structure of a manufactured home. So if at all possible, seek a more secure shelter, similar to what you would do for a tornado threat. So lightning, this is a thunderstorm hazard. It's not actually at all a severe criteria. If you noticed, it wasn't in that list we talked about at the start of the video. But it's an important thing to note and important to take safety precautions for as well. So lightning refers to an electrical discharge from an uneven distribution of charges between clouds and or the ground. And there's three major types of lightning, just based on where it starts and where it originates and where it's traveling to. You have cloud to ground. These are the particularly hazardous ones because they interact with where people are on the ground. In cloud and cloud to cloud. Those can present some hazards for aircraft, but there are precautions that aviation takes into account to minimize threats from lightning. Still, though, can be a threat. Heat lightning may be a term that you hear about or are familiar with. That isn't an actual type of lightning. All that refers to is visibly seen lightning that is so far away that you can't hear the thunder from. And typically that's because there's enough clear air and the temperature profiles are right that you get refraction. So you're seeing lightning that's actually really far away, but it looks closer and it actually can look like it's on this side of the horizon because of how the light refracts. You also may have heard of ball lightning. That's a really rare and very poorly understood lightning-like plasma phenomena. Some people hypothesize that it doesn't actually even truly exist, but there's been documented occurrences of at least some plasma ball lightning-like phenomena that is associated with types of thunderstorms. So there, unfortunately, it hasn't been enough consistent occurrence for all of it to be tracked down and well understood scientifically. But it's still something you might hear about when you talk about lightning. And just a quick note or pet peeve correction or whatever, it's lightning. It's not lighting or lightening. So, sort of spell it correctly. It's lightning, not lightning. But anyway, of course, I say that and I'm stumbling over my words trying to talk about it. But anyway, we talk about the impacts and threats from lightning. Direct threats to humans, burns and electrocution. This is of it, again, relative to other types of hazards from severe weather, relatively rare, but it still happens and it's still something you don't want to mess around with because it's particularly deadly if you get struck by lightning. This is really intense electrical discharges. If people even aren't around, though, can still start fires, a very common cause when you have lightning storms over areas that experience drought and forests that experience drought. You can get wildfires started from these, or just general structural fires or brush fires if lightning strikes. In the United States, generally lightning intensity, just due to oceanic convection, hurricane season, and all of that. Florida really is your hotspot for lightning, and it tends to also be where there's the most fatalities from lightning as well. The greatest risk for lightning impacts is for those partaking in outdoor activities, especially things where you're the tallest object around or you're interacting with metal. And so the saying, National Weather Service, probably a little trademark phrase, is when thunder roars, go indoors. And that's really true. And it's really something you don't want to mess with. So if you hear lightning, just go inside. And if you absolutely cannot find shelter for whatever reason, the idea is you want to make yourself least likely target and least likely to have residual impact from a lightning strike. So stay away from trees and from other tall objects where you can get residual discharges from, and remain low to the ground so that you're not as much of a target yourself. The final thing is, don't just lay on the ground, because the more surface area you have in contact with the ground, the more likely you could pick up just discharge from ground surface interactions. So usually best to be in a somewhat awkward position, but sort of just on your feet, but hunched over as low as you can be. The other thing is, if you're outside away from shelter, but you at least have a vehicle, it's much better than nothing. So because of the metal shell of the vehicle, it can at least tend to conduct electricity around the path and protect the occupants inside. It's still not perfect protection. Still could be hazardous. There still could be stray discharges. So it's not as ideal of being in a well-grounded structure, but it's much better than being out in the open. That brings us to sort of the last section, and really if you had to take away one section from all of this severe weather, severe thunderstorm talk, it's probably this section. This is, in addition to those safety precautions, sort of the things that really hopefully will help you address and respond to severe weather yourself. So a big thing want to make sure is clear to everyone is the difference between a watch and a warning. Those who aren't used to the terminology, this can end up being confusing, but hopefully you see it here in class, you see it on social media or from other learning sources, but you know very carefully what the difference between a watch and a warning is. So a watch, conditions are favorable for the development of severe weather. Really going back to our past discussion, it's the ingredients. A watch means the ingredients for severe weather are there. And if a watch is issued for your area, that really means you take your early preparatory actions. You make plans for what you do if a warning is issued. You make sure you're paying attention to your source of severe weather information. You don't have to shelter yet. You don't have to take all of your other precautions yet, but you need to be aware and you need to be prepared. A warning, though, that's a different story. That's where you actually have severe weather that's occurring or is expected and imminent for your area. And this is where you actually should and need to take protective action immediately. So this is where you go shelter. This is where you bring your things inside and head down to a storm cellar or a storm shelter, something like that. And maybe you've seen these kinds of posts or these images before, but a cupcake watch, you have all the ingredients. Cupcake warning, it's actually imminent. So sort of looking at just comparing what these look like, a watch, they're issued by the Storm Prediction Center, the SPC, in Norman, Oklahoma on a nationwide basis. These tend to cover broader areas. That's why they're centrally managed by the expert severe storms forecasters at the SPC. Warnings, on the other hand, are much more locally dependent and factor in a lot of other concerns too. And those are issued at your local National Weather Service offices on a county based on their jurisdiction or their county warning area. And nowadays, both watches and warnings are drawn out using polygons. Watches typically are these broad parallelogram areas that cover many counties. Storm-based polygons for warnings typically only cover part of a county or they overlap maybe just a few counties. But it's no longer just based on whole county warnings. That was the old system a while ago. Now these are polygon based. So if you're actually in the area of the warning, you know you're under threat and you need to take precautionary action. So again, how do you acquire this information? The key thing is never rely on just one information source. You should always have multiple sources. And the big thing that all the experts I iterate, the best source for acquiring severe weather information in the US here is NOAA Weather Radio. Preferably with SAME, and most of the ones that you'd buy these days have that. What that basically means is that it's localized for your particular location or subregion in your county. So you're only going to get alerts if it's a warning impacting you, not just anywhere in the area reached by the transmitting station you're picking up on. The next best, luckily these days, smartphone cell coverage is typically really good across much of the central US, and there's the wireless emergency alert system where particularly bad severe thunderstorm warnings, if you opt in, and tornado warnings by default, you get a non-mutable notification on your smartphone. And so that's a good way to get, and their precision tied to your location as well. And these, nice thing about smartphones is they have internet access as well, so you can follow your National Weather Service office on social media. You can also your trusted local news outlets as well. You can sign up for text alerts of various kind or go looking yourself for apps and websites that have good up-to-date real-time info. So what I'd recommend for most college age people these days you already have your smartphone, make sure that you have the tools you need to get good immediate access to weather information, and then combine that with a NOAA weather radio for the case that you say run out of battery on your smartphone or any other case, so that you can get a good reliable signal directly from the National Weather Service without any of the delay of disseminating information over the internet. But there's other information sources as well, just general internet that you get on your computer, tablet, anything like that. Local TV and radio stations should not be ignored either. They have a duty and they provide similar channels of information as well, but maybe aren't as widely used among a college age population. Also, outdoor sirens. You're probably well aware, if you're in Iowa, we just, what was that, Wednesday, had a monthly test at 10 a.m. of our outdoor siren system. The big thing about outdoor sirens, and this is a common misconception, is you should not trust outdoor sirens if you're indoors. That's not at all what they're meant for. Also, that you should not rely for outdoor sirens in places that there aren't sirens, so away from population centers and towns. Outdoor sirens are for people who are working and doing activities outside where these other primary sources of warning would be hard to reach. It's sort of a last fail-safe to reach those people that are outdoors. Should not, again, be trusted as your definitive thing if you're inside. You should rely on things like weather radio and your wireless emergency alerts on your smartphone. So that wraps up, and just looking at the time, I apologize, I went really over on this video, but there's a lot to talk about with severe thunderstorms, and honestly, you can probably take entire classes on this kind of stuff. I know it's my interest area, so again, if you have questions, feel free to reach out to me. I'd love to talk more about any of this. But to wrap up, there's other major severe thunderstorm hazards didn't talk about here. Tornadoes and flash flooding, both those are going to be covered next week. And if you want to learn more in particular about these severe thunderstorm hazards, phenomena, or what to respond or how they come about, or you also want to put the knowledge that you learned here or knowledge that you've learned in the past or want to learn going forward, you want to put it to use to help serve the public, become a skywarn weather spotter, skywarn storm spotter. The Weather Service needs ground truth. Radar and models can't tell them everything. So there needs to be people on the ground. Nowadays, with smartphones and social media contact, with georeferenced pictures are great to be able to verify hail occurrences, wind damage, and tornado or rotating wall cloud occurrences to be able to give the Weather Service, the warning meteorologists, the information they need, that ground truth, to make the best warnings and forecasts possible. For this, I have a couple links posted here. I'll also have those in the video description. Feel free on your own time, if you're interested in this, to check those out. And again, that wraps up our severe thunderstorm section. Next week, we'll be continuing on with some of those severe thunderstorm hazards and continuing to other severe and hazardous weather, from tornadoes, flooding, and then tropical cyclones. And I will see you then.